So it's time for the second talk of today from Master Masterpiece with Sven Ruppert.
So, thank you very much. I will slowly start with speaking because I have no idea how loud it is. So, okay. Who's coding Java? Hopefully a little bit more. Yeah, thank you. Who's coding with projects that are running 6 months? Longer? 2 years? 5 years? 10 years? Yeah, welcome. Java 8 in production. Okay, nearly the same. 7? 6? 5? Okay, someone from automotive or military also? Okay, good. So for me, it's mostly the same. So today, I want to talk with you a little bit about this getting a huge amount of lines of code and then start working. So I'm working since 1996 with Java, and it doesn't matter if I was in automobile industry or something else. Everywhere the same. We had this huge amount of lines of code, and then a lot of developers that are very high motivated and working on this code, learning something because they were reading something in some magazines, and then immediately they have to use it. Okay. So, well, what I want to say or to explain today, it's a little bit the story of the last 3 years. So the thing I was working on is a code base more than 13 years old. And who's working test-driven? Okay. Do you have colleagues? I mean, colleagues that are working test-driven too? Wow. Yeah, a few hands. Okay. For me, it was more or less the same. I had a very great test coverage for this project, and not only one single line of JUnit test. Nothing, really nothing. So, and this since 13 years. And one very special thing is, I don't know if you know this, in German it's called code lord. It's a guy that is responsible for a module, and it's his module. Definitely his module. Yeah. So we had a few of them. And there was one special thing in this environment I doesn't had before so often, but slowly we are running into the situation that we have a huge amount of developers inside the project that are retired soon. So they will say to you, hey, come on, I'm working here since 15 years, everything's working, and I have to survive the next 3 years. Why changing something? It works. Huh? So, and we had a huge amount of this, and the most developers in this project were working quite a long time in this company, and they never saw something different. Never. And the worst thing was they are only hiring students instead of me. Well, but they are hiring students. And this means that the most developers learned Java only during working at this project. Imagine what happened if you're getting a few million lines of code that were produced in this way. It's some space for improvements. So I joined first as a consultant, and the first feeling coming through this project was more or less like this one. So there's this huge castle of source code, and all these code lords in front of, and they're protecting everything very well. So the first question the CEO asked me is, what the part of refactoring, or what is part of refactoring, what we have to change? And the answer was longer as he expected, and longer as he wanted to hear first. So part of the refactoring is definitely the team itself, because if the team don't want to refactor, then there's nothing you can do. Sure, the source code is part of refactoring too, and this really hurts the processes. There are some things why source code is in a way like you will find it, and the project management could be part of the refactoring itself, because if you haven't the space or the processes or the way of handling different things, you can't change the whole system. And the knowledge. Sometimes I have the feeling a developer is coming from the university, okay, maybe it's 5 years ago or 10 years ago, and then he told me, I learned everything at university. They prepared me well for the rest of my life. Sure. Maybe I learned not enough at the university. I'm doing it every day. Could be. So, one important thing is budget and timeline. So, in this special case, I'm working for a product company. So, it means that we don't have to fulfill a customer request and then never touching it again. So, we really have to live with this stuff we are building, and yeah, we want to survive over a longer time. The infrastructure itself is sometimes part of the refactoring, but if you have all the things you want or you could change, you could divide it more or less in 2 groups. I called it, there's a C-level transformation. That means that processes, budgets, strategic targets, whatever, this is not part of this talk. It's far away from me. But all the other things, that is something that's quite near at your development things. So, well, let's say we're getting rid of the C-level stuff and only showing here at the developer things. So, if you start with refactoring, you have to start somewhere. And the main thing is that quite a lot of developers say, yeah, we must change something. And then you ask, what? Silence. And then the other answer is everything. So it's mostly good if you start really, really, really small. So with a single thing to learn what's going on. But don't forget to think bigger so that you know what could happen in the future. This is good because this you have to explain where you want to go with all this stuff, and the way between is quite good. But if you're working alone, it's really a tough job. So the next thing is you have to find a team in the team that will support you during the time you are refactoring bigger things. And if you have a team, or if you're building a team inside the company that will work hard on this stuff because it's mostly additional work in the beginning, you have, you need trust. Trust means that the people that are working with you and this management and all this stuff will think, okay, if he is doing it, it will succeed. It's one of the most important things. And if you don't start with this one, mostly you're only changing a few technical things. Okay. The first thing was, during the time the developers were working, they had no time. Oh, I have to do this and that, and no time to change something, and it's a huge amount of work and all this stuff. So the first thing we have to start with there was we had to change the way of working so that they're able to change things. And this was quite a tough job because you have to deal with different parties in the company, and you have to deal with project management, with a lead at some departments and all this stuff. So what we introduced is that we had the goal to work from everywhere so that you can divide your days. We had start with 20% time, and the decision was open source, closed source, start learning again, and all this stuff. So the thing first, we introduced it working from everywhere, so that everybody had the freedom to work on these special things if he is in the right mood. So if you're coming from a huge meal, and then, per definition, it's time to be creative, well, could be a challenge. Mostly, the guys are running around with a cup of coffee and try to survive the first hour after they had a big meal. So, This means to work from everywhere, we had to change the environment. And one easy thing, but it's mostly forgotten, so they're not thinking about this, we use a free messenger. Okay, if you have a problem with security stuff, install something internally. But we're changing to a messenger to avoid mails, and this was reducing workload. It's quite easy, but at the same time, we start remote meetings with Zoom. I don't want to make a product placement, whatever, but the cool thing here is 50 guys, 1 hour for free with everything you need. So you don't have to invest money in the first thing, and then you can try to play around with remote stuff. Okay, show me a screen, and I do something. So we were able to have remote pair programmings. So they could stay at home because they have to get the children from the kindergarten, but during the hour they have free, they can do something useful, even if it's only code review with a colleague. But this means that you have to start work asynchronously. Quite often processes are in a way that you now this, now that, now whatever, so everybody's waiting and so you're losing a lot of time. Working asynchronously means that you could work at the time that's best for you. If you want to refactor, be creative and whatever, maybe it's not the right time to get you out of the bed at 5 o'clock, to be in the office at 6. Okay, who has kids? Okay, you are in the office at 6. So, what's the best time for me, or for you itself? It really depends on the project structure. So, my normal day is something like I'm really getting up early because I have small kids, and the good time to work without any interruption is between 5 and 6 in the morning. Then I have breakfast with family. It's good. I can bring him to the kindergarten, do something useful, so I'm part of the family. And then I'm working again until I'm grabbing all kids back from the kindergarten. Okay, time to play with my son, time to play with my wife. And if everybody is sleeping again, working. Finally, I have time to do something. Huh? So, okay, a few of you are now calculating. Yes, mostly I have only 6 hours, but doesn't matter. But why? Why this could be useful if you're dividing your day in several parts. Because quite often I had projects around the world. This means in the early morning I was working with Asia, during the main time I was working around with my colleagues in Europe, and then later I was working with US. If this is good for the project, maybe this is the goal. Don't make it too long. So we changed it, it was good, and to have a little bit free time, we reserved some time for things, but it must be really reserved because we need budget for the time. If a developer is 20% of his time doing something that's not related to a project, immediately the management will ask who's paying for it. So, but how to explain? I explained it in a way like this. Lost in daily business. So every developer in my team, so this is a bath, and this is I don't know, it's the English word, if you have soap and making all this stuff, bubbles. No? And with this 20% time, I was able to give them a little bit like, well, to have a small view. So now I have a little bit time to look around, see what's going on, and I have the first possibility to move a little bit left and right. And this was really important, because before I'm discussing about what you're really doing, I must have time. And this was the board accepted this and says, okay, makes sense, start. To make it useful, quite often I have the discussion then for the developer. The developer would say, yeah, I want to read this article, that article, and says, okay, what's related to the project? We want to change something internally. And the next thing is the company is asking, make it useful for the company. So we started something like every week we have 1 day free. Then we are working 3 weeks in a row without having 1 day free, because then we have 3 days. And with these 3 days, I'm living in the south of Germany near the Alps, means that we are packing all our stuff, going to the mountains for 3 days. We are off, but then we have 3 days in a row with any disturbance, and we can work. And this was really, really high productive. And the other thing is, you have every week 1 day to save. That means I need 3 days to go there because I don't want to go over the weekend or whatever. It must fit in the middle of the week. Monday is a bad day, Friday is a bad day because everybody wants to go home. So you have only these 3 days in the middle. Reverse around, it means that over 3 weeks you can prepare everything to have this 3 days free. So everybody would say it's only over 3 weeks we can prepare. And the team was highly motivated to prepare everything to have the 3 days. And then you can do it every day again. The next thing is we started refactoring. We had a huge amount of code. And then I started analyzing the existing code. Because if you have a project that starts 15 years ago, you start with a lot of things that are not existing during this time. In our case, it was a lot of infrastructure code. Today, the most of this you can get for free, with high quality, you can buy support, whatever. And now, what we have to do? I divided it for the board in a part of, with this part we are earning money, with this part we are not earning money. And the part we are not earning money with, I want to have the freedom to grab it out. I don't want to replace it immediately, but only have the permission to get it out of the normal processes. So with this, we are able to divide the code base, open source and closed source stuff, because with this we are not earning money. But at the same time, we were able to divide the complete environment. And this was a huge task and a huge possibility. Because if you start dividing the code base, then it means that you can discuss at conferences or write about it or whatever. So the open source stuff is now free. So the people can talk freely. They have no limitations. They can use it as a playground. And in our case, it was leading to a better documentation as we had before. Because otherwise, who's writing documentation for his code? No, I mean really a letter and fully sentence and all this. Yeah. Me neither, I don't like it. But in this case, we had indirect documentation. The next thing is dividing the development environment. This was a cool thing because we are immediately out of the company rules. If you're working in a huge company, who's working in a huge company? That means more than 100 guys, 200 guys or whatever. Do you have a department for security? Or something like rules, what environment you're allowed to use? Who can choose his IDE freely? Yeah. Okay, more as expected. So we had the free choice for the open source part. Now we were able to do different things. So I was going to companies and says, okay, there's an open source project. Could I have the enterprise license for this open source project? And they says to me, yes, you can. It's good. So we started immediately GitHub, then commercial tools for the open source license and so on. So we had 2 different development environments, really divided development environments. So this means the free choice of tools was really good for them because now they could start and they could make mistakes because they get rid of mistakes again because they could change it immediately, no discussions, nothing. And this immediately was leading to higher motivation. So the guys immediately start playing around with tools. They haven't done it since years before. Yeah, we have this debugger. It's good. Well, we have this debugger. Okay. So, but now they can play around. And then you have 2 environments, and then you can show immediately, okay, lovely board, see what we could do here with this, and how many metrics and code quality and all this stuff we can generate, and what we have to deal here with. So, and this was really good. But if you have a team and you don't want to replace it completely, you have different kind of reaction there. So the way of working will change. That means that you have to start learning again. And for some colleagues, it was really pain in the ass. So, for example, you could say, okay, now we start learning about focusing on new paradigms, or we can say now we want to have a little bit more functional stuff or reactive stuff. Maybe if you are really highly motivated, you can say, okay, we're adding a new language. And all this stuff is focus on one, don't do everything at the same time. But not everyone wants to learn. Some guy says, hey, I know it. Or if you want to say it a little bit more polite, some are learning faster or whatever. But with the rest of your team, you have sometimes some reactions. And so it turned out that we always have a few groups that are the same. So some reaction on the team where the running away guy. So this means he always say, yeah, I want to do it, sure. Oh, sorry, there's this project, and then I have to do this and that. And so he always say, yes, 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 I want, but he will find thousands of excuses not to being part of this. The next one that we had was something like, they are always expecting something. So even if it is really nice, there's something that could bite me. No? So you have to deal with these guys, and then we have this really, no, we are all dying. I'm lying down there, and someone will only close everything that's on top of me. And so, okay, feelings in the end. And sometimes we have the last group, they're only feeling too old. They really say, no, it's not my time anymore. I'm done. Okay, good. But the problem is if you don't want to get rid of them, or I'm not a fan of changing teams, so I want to have all of them on board. So you have to deal with them. And the most thing is, if you don't want to lose them, you have to deal with all these different groups and make sure that you make them happy again. But the biggest thing here was how to make them happy again. You can't go to everybody and say, you have a little bit more income, now you're happy per definition. Well, could be a challenge. So one key point was changings in the project management. So have in mind that we are a product company with a lot of really long-term support contracts. That means we started creating 3 streams inside the company. We have this consultant. This is this type of guy that, oh, yesterday I found out there's a new beta version of this library. He immediately is grabbing it and pushing it everywhere. And this is all this consultancy stuff. So really fixing things fast, but not thinking about that he has to deal with this next month again. Then we have this type of core developers. Core developers are 35 until 45. They bought a house, have 2 kids, need a stable income for the bank. Yeah, they are learning, but slowly. They have some risk to avoid. And then we have this kind of long-term support developer, I call them. If you have any better polite name, let me know, please. They learned how to do something, and then they want to keep alive it. Never touch a running system. Never. So, why? Why we divided, or we created these 3 groups? Some want to learn and experiment. These guys, you need to explore new things. It's good. Some need more stable environments because their family and their social environment will force them to be a little bit more restrictive and don't take too many high risks. And some only want to survive. They don't want to change something anymore. And this you could really match to this group. And this is not bad because you can start changing the way they are earning their money. To force them to try that they have a special behavior. For example, the consultants, they are paid by the amount of hours. Yeah, the customer will pay 10 hours, and then he will immediately jump in and waste this 10 hours. He's going back to the CEO and say, you can bill 10 hours. Yeah, good, fine. And then he has to deliver fast. The next one, the core developers that are more internally, not traveling and have the stable environments, they will be paid by how stable the system is. And the last one, they will have more or less a fixed income because they don't want to change something, means that they don't change the income anymore. It's good. And if they want to have some extra money for Christmas, they can work on change requests, slow running, small changes with a long term of preparation. And then you can divide the project management into 2 parts. Consultants and long-term support developers, they are mostly customer-driven. So the customer says, I want to have this feature or whatever. And this, we started with Scrum base, so fixed time slots. And the core developers, we don't want to have them with this pressure from the market in this way. We want to have only bundled features to have a new version. So here we decided to make it like Kanban. But Scrum and Kanban, well, who's using Scrum in his company? Okay, anybody with Kanban? Who's mixing both? Wow, okay. After the talk, please come to me and explain how you are doing it. Because for us, it turns out one size fits all was a bad idea. So we had the Scrum-based stuff with time-based things and the core developers. But if there is a huge break somewhere and we have to do something, we define, okay, there's a fire, and then both are working on this. So both project management things are stopped, and then they're working on the fire, and then they're back to the thing. So it's more or less okay. I think it's common, but it was not so easy to explain at a board that you don't have one project management over the whole company. This was a bigger thing. And the next thing we decided that long-term support developer track and the consultants, they are time-based, but with different lengths of the slot. So the long-term support developers can have a sprint over 4 weeks, we don't care. But the consultants that have to deliver fast to the customer have sprints 1 week, 2 weeks, whatever. So shorter. But time-based planning, and then we have these core developers with not fixed time slots so that we really could work version-based, and this was increasing quality immediately. So, start learning again means that after we have all this stuff done, we build a source of knowledge, and this year you can buy huge systems. We are using Slack. We have different channels, and everybody who found something that's interesting only pushing the link to this Slack channel. It's good, because then you have over the time a list of things that you want to use, and then we start using this, for example, okay, now we want a functional hacking session, or someone is writing blogs and articles, or screen card that someone could use in the company to say, okay, this can we do in this way or that way, or even we say now we want to have a dedicated proof of concept if something is really important for us. The other thing is that we are using this knowledge base definitely to have refactoring sessions. So we see, okay, this is cool. Now we are refactoring explicitly this one. How to motivate the team? Sometimes it's only a question of time. You have to explain it, explain it, explain it, and explain it. Some guys are doing it fast. So choose your weapons with the technologies. If you're asking consultants, for example, you have an external consultant, and then he will change the world for you. To scale and change things, you need at least, at minimum, one NoSQL store, Akka, Scala, otherwise you are not able to change something. Events, it's really necessary. Everything must be reactive now, and functional is a very nice thing. So maybe. I have no idea. I know it. I was consultant over 20 years, so I know I'm giving this answer if I'm a consultant. No, maybe. I have no idea. Not a consultant right now. But we focus on stuff like Java object-oriented. Okay, they know. We only focus on, okay, now with core Java, have functional reactive aspects. And then nothing else, only this, so that a fully team could join what you're doing. Or we have this JDBC result set stuff. So this old, yeah, we are using this self-written object relational mapping stuff. And then maybe you can say, we want to try something new. We want to go to streams, try Speedman or whatever. So it's open source. Swing, we want to go to web. We have this fat desktop thing. Okay, maybe the right thing so that they can use everything they learned is Vadim, because it's the same way of coding. Or I have a hash map, it must be distributed. Okay, go to Hazelcast map. But it's a map. It's nothing fancy, new, big environment. It's only the same data structure, but with a different behavior. So what's the right technology for your team? I have no idea. But I could say, please, please, please focus on small things and don't invent huge things at the same time. What's the right order is the next question. Well, it really depends on the team. So it must reduce complexity. Quite often I see, yeah, we want to change something. They're building a huge system nobody can maintain. Okay, only the consultant that's implementing it. The team must work with this. So if the team is not able to deal with this technology, please don't use it for refactoring, even if it is a better technology or whatever. So you have different ways of deciding what's the right thing. Do it with your team together so that everybody will follow you. And then start with new modules. Well, we started with this, and it was a bad idea, because the difference between the oldest module and the newest module was even higher and longer, and this was not good. So we decided to start refactoring and cleaning the oldest module, because this was farthest away. For us, it was a really good one, or the most complex one. And one thing we definitely decided, the first thing we are refactoring is the most complex one, because if this is working well, all the other stuff is easy, and we can pay for it. Okay, you have different ways to decide. I only want to give you some examples, but make this as a clear, open process. One thing that would limit your speed, or even in the company I'm working, is over the time and the number of versions of the product. If you have a linear increase that was leading for us into something like, okay, one guy was maintaining 10 different versions of the product. And he was the only one who knows it. And then the next guy who was the next few versions. So we decided we start with a huge amount of changes. Then we have a time that will be fixed so that we can learn all the stuff we have changed. And then we are changing again. And with this, we had definitely better quality results. The stabilized phase here is depends how long this could be, is the project lifetime. For us, the project lifetime is 10 years or 15 years. That means this lifetime could be 1 year for us to learn, only to stop, learn 1 year, then we have all things from a fiscal year, so beginning of a fiscal year, end of a fiscal year, and all this stuff. So we know, no, we had all phases, we learned, and then that's it. So for us, it's 1 year, maybe for you, completely different things. We have this refactoring safety belts. If you start with refactoring, then we had the problem, do you have bugs in your code? And we are asking maybe some from the management. The answer would be no. Yeah, but he doesn't recognize that we are not the customers. Huh? So, because since years we were working hard on it, and you have a picture like this, so wow, we are strong, we can do everything. But remember, our code base was quite long, and we have no test coverage, oh no, and we have to decrease complexity. I only want to jump in with one thing. We started with mutation testing. I gave last year a talk about it, so you will find this one. But it turned out that mutation testing was really good thing. Only to show it, I don't want to explain mutation testing again, is that you have a tool to decide not only what are the right tests and how many tests you write, you have a very clear way of doing it, generating mutations, running tests, check reports, and all this stuff. And this is an iterating thing, so you can put it into your cycles quite near, really good. The next thing is that if you're working with line coverage before, you have these reports that you say, first test will give you a report on line coverage with, yeah, nearly everything green. Next report is completely everything green, but with mutation testing, you will have something very special. Every class will give you an amount of mutations. And the report here is so detailed that you can use it not only for the development report, you can use it for the board itself. Because if you have here the possibility to see what mutations, so that means what kind of work you have to do to make your test good, with the really detailed instructions, what you have to do, and the high-level thing, it turned out that with this high-level report, I was going to the board and says, okay, this is the amount of risk we have inside. And then we looked at different modules and says, okay, the module A, we want to earn money next year, 1 million. And with this module, we want to earn only 100,000. So this 1 million was a leading one. Okay, then we have the amount of technical, whatever. We have to work on it. So that means it was a clear decision that we focus on this module, and with this mutation test report, we were able to say you can focus, or you can get a report every morning how many mutations we killed during the last day. So you can track us. So that's not something, whatever. You can track us immediately. Okay, I want to have this report. Immediately I was saying to him, yeah, mutation testing is slow. We need 50K for a small server to generate this report. Yeah, it's okay. Weeks before, I was asking for a continuous integration platform. No, please use something that's existing and, well, maybe if it's working, come to me and say how much it costs. But with this report, it was quite easy. It says, report for the management board. Yeah, here, you have the money. 1 million we want to earn, 50K you want to have for this server immediately. And this was a base for our continuous integration platform. Good. So now Team City is generating every night a mutation test coverage report. Perfect. So try to explain it in reports. Okay, so this means mutation testing is only an add-on to JUnit, so you can do this, and you will see that even the developer will work on it in a very strong way, because mutation testing will lead you to cleaner structures. It's really time-consuming to generate, and this means that they start making smaller modules to reduce runtime, and this is only an example. This was original code, how to write tests for this. You need a few minutes to understand what's going on here. But the result after mutation testing was something like this. I don't want that you understand all lines, but the main structure of this is version 1, and this is version 2. So with mutation testing, it's quite often going to cleaner structures, because then you are writing easy tests. Okay, and you can find useless codes. This is the main thing. You will get reports like, oh, there's something, you can't kill a mutation, and then you see, okay, this is really stupid. Get rid of this code. The main thing is here that if you're starting at this, you start thinking about functions. So now we are on a code base. Code base means that the people want to use the new features, and you have to start thinking in a different way. For example, if you have code like this, the first experiments will lead you to stuff like this. This is a very, very short example, but it shows quite clear what the problem of this is, because you only want the difference between G and I, and the rest of the code is completely the same. Yeah, it's functional, it's cool, huh? But I only want to change this one. If you start with this, then mostly the first things are leading you to stuff like, okay, I have this consumer method reference somewhere, I have a variable where this stuff, then I can extract this predicate for the stream, and then I can write something like this. Okay, but if I'm starting with the next one, there's one big problem, because it must be final. Good, so I'm winning nothing. The way you have to think about is now, if you start with these functional things, that you are working with higher order functions. It's, yeah, think about it and go directly to this way of thinking, because you're changing all this stuff to streams, and then you're replicating code, and then you have the possibility to write things that you can reuse and only switching to one thing that is changing. So it's only a small example, only to show you, okay, if you start with this, well, play with this. Looking at the time, we have 10 minutes. Who's working with functional interfaces and streams in daily life so that he's used to read stuff like this? Okay, the most. I will switch some slides to have something more from interest. So, one thing is, changing of design patterns is if you're writing something like an interpreter, or if you have, for example, proxies. Proxy is a fine thing, because now you have proxies in the JDK. You don't have to write them by yourself. But an interpreter, for example, pre-Java 8 implementation would be something like, you have an expression and you have operators, left side, right side. Then you have to implement every operator by yourself, and add and sub and whatever. And then you have operations, and then you have numbers. Okay, you're implementing this stuff. And if you have this, you have something like getting an operator. So something in a string will lead you to an instance that you're using. Okay, this is really Gang of 4 pattern stuff You can read it everywhere, that's it. But if you're now changing more to this functional way, oh no, this only is interpreter and then the thing itself. So breaking this thing, checking if it is an operator, left, right, otherwise number, and then the stack-based stuff, so that you have here, this is way of numbers and operators. So it's more or less, well, you're not using it in production, but it's only to show what's going on here. You could change it in a way that you say, okay, if I'm using Java 9 or Java 8, there is an operation with a logical identifier. You can do something like this, and this I quite often see. They are working now with lambda expressions somewhere, so that they don't have to implement a class add and sub and something, but then they are pushing this stuff to a shared data structure. Well, you could do it. Then the implementation of the same is very, very short. Well, but the main idea you can focus on if you're switching to more functional ideas is data structure to function transformation. If you have something like this, it's really the first version. So get rid of implementation and putting it somewhere like a lambda expression or method reference stuff. But this is a data structure. You can transform it to a clear functional thing so that you don't have a shared data structure, but you have a function that you say, okay, a function that will have a string as input, but will give me a higher order function back. So this is a main idea that mostly lost during this refactoring things. This is an idea. If you want to see more of these examples, then you can go to this functional reactive stuff. It's I'm writing slowly all this stuff there, so you can play around, even if you are playing around with memoizing. 7 minutes. I can show you one example that is maybe interesting for you. That means, who knows what memoizing means? Okay, for the rest. Memoizing is the easy thing. Oh, I don't see this one. Wait, I don't want to bore you with private pictures here. I want to have my IDE anordnen, Bildschirm synchronisieren. So, okay, come on. Now, finally you see something. Good. No, this one. Memoizing. Memoizing is something, you have a function and you will feed this function with a value, for example, a, and then you're getting a result. If you give this function again a, you want to have the same result. If you're working with primitives, the result is 1, then it's easy because you're getting always a primitive, there is no identity of the object itself. But if you are getting back a value like a car, then you want to have not the same, you want exactly the same car. So the same object, not the same values. This means you can think in a way like caching, partial caching. This means the implementation of memoizing on this functional reactive stuff. So it's really the full example. You can say, okay, I'm using more or less this. There is my cache, my local cache more or less. And if the value is not there, please use this function to calculate it once. That's the basic idea behind. The main thing is that you have to transform curring and uncurring your function. The most description on the net I found is that a by function will lead you to a function of int that will give you a function of int to int. So, because the function has only one input parent. And then you have to transform it back. How to do it? You can read there slowly. But what I want to show you, if you are dealing with legacy stuff, this could give you some idea. Let's say you have a legacy class. Something, it's not a functional interface, it's somewhere inside the inheritance, it's whatever. But you have something inside coming, and then an object that is legacy 2 coming out. This legacy value class, I only created here in a way that it says, okay, there's a timestamp, only to see it's created once or twice or whatever. So no really special meaning behind. Okay, if you have both of these, you can do something like the following. You can say, I have this old thing, okay, and now this line here is for the most not really intuitive, so the thing they are doing immediately. you can say, from this dedicated ID, I will get a method reference. And this method reference you can call immediately to a by function, because the only thing is 2 params in, 1 param out. The typing could be int input, my legacy class value output. It's quite easy, and you can do it. If you have this functional interface now, you can use this memoizing stuff, it's generic written, to give the functionality of remembering results to this instance. So I can use this method reference to get a by function out of it. Then I have this generic way of memoizing without changing the original, so you're not touching old code. And if you then check what's going on, you will see the following. The memoize function will remember results. The original one will give you always a new result. And you can start caching on big objects on method base without introducing JCache and whatever. Sometimes it will help you, and it's only so much code of core Java. Well, time is more or less done. I would say we have some ideas what refactoring could include. The main thing here is if you say, okay, we have a summary, change the way of working, prepare your team. Project management is definitely a way of thinking about if this fits. Build a safety belt to make it clear for the management team. You could use mutation testing because you have really clear and strong reports. You can maybe divide and conquer this stuff if you start with dependency injection or check core Java pattern like proxies. This is cool. Clean your code, really make all the things on level 8 or whatever you want to use, and don't use legacy stuff. If you have to explain it to your C-level, it's quite easy. Problem solved. And otherwise, I would say thank you very much. If you want to read more about it, functional reactive is something that you can use. There are all the examples. And maybe soon there's a book in 2 or 3 months, and Java 9 org is explanations of all these steps. If you want to help, please feel free to. Otherwise, I would say thank you very much. If you have questions, I'm running around here the full day. Come to me, ask things, show me your code, whatever. I'm happy if I could code or do something. Okay, thanks.